Find the inverse, determine if they're inverses. And you can do those problems just like we did that. You don't have to necessarily go back. We did do section 3, graphing calculators. 7.4, 7.4 and 7.5 and really 7.6 are all pretty closely tied together. They're all solving square roots. You basically just need to know all those rules to be able to apply them, because the test is not going to have it divided up into those 3 sections. 7.4, I think they all pretty well work. They're all perfect squares or perfect cubes. And then 7.5, we ran into where they were not. So 31 plus or minus the square root of 256. Remember, this is where we had those rules. You got to remember, you cannot have a negative under an even radical. You have to remember to mark those no real solution. Remember that you have to put absolute value. Does anybody remember when you have to put absolute value? For this set of circumstances. Has something to do with the index and the ending exponent. Right. So how do you know if it should be an absolute value? If this is even, if your starting index is even, and then you end up with an odd exponent. So for instance, what's this index right here? It is squared. And if you were to end up with, and it doesn't apply to numbers. You gotta remember that. It's just the variable. So if you had an x under there, that would be squared, and if we ended up with just x to the first is odd, you would have to put that in absolute value. So remember those rules. Might be worth it to check that table that's in section. Always check first to see if they're perfect squares, perfect cubes, using your calculator, especially on bigger numbers. But check that before you start to try to simplify. So it is 256, a perfect square. What's the square root then? 16. So the square root of 256 is 16, and you just add the plus or minus. Any of those signs out front, you bring those right down. So the next one, the cube root of negative 216. So can you do this, or is it no real? Why? Because you got an odd index, so that's a rule right there. Sounds like most of you got. So we can check. Is 216 a perfect cube? Negative 6 is correct. Number 33 is the square root of negative 8 squared. Now these you kind of have to be careful on, because most of us want to just cancel the index and the exponent and be left with what? Negative 8. But what you have to realize is if this negative 8 is in fact being squared, then what does that mean? It has to be positive. So another way to look at that is just to actually square negative 8, and what would you get? 64. And the square root of 64 is 8. So that way you will get positive 8. So just watch that. It'll probably be on the test. Fifth root of c to the 5th, d to the 15th. So again, section 4, they all work out. So what do we do with the exponent and the index? You divide them. So is it index over exponent or exponent over index? Exponent over index. So for this first one, 5 over 5 would leave you with c. 15 over 5, you'd have d to the 3rd. Do either one of those need to be an absolute value? You get an odd exponent. But you have an odd index. Very good. square root of x to the fourth minus 3, and that is squared. So these problems are actually easier than the ones where you don't have parentheses under it. What do we have to do here? Do we do anything with that with what's inside there, Prince? No. So what we do is divide. You have a squared here. Divide those two. What's left? X to the fourth minus 3. Yeah.
Tell me how on 8 we would do that if we do it on that one.
On here?
Yeah.
That's the tricky part, because this has to be a positive number. This one, it's variables. If you just cancel that and are left with the -8, it is kind of hard to explain. But you can't actually square this out. You do know that has to be positive, which is what I'm waiting on somebody to tell me. Since it is being squared, this does have to be positive. What kind of number is this? Even. What's our new exponent? So you have to have absolute value. So that's what this takes care of.
Would you make the make -3, and then would you make that plus sign?
No. Don't change anything inside the principal. What's inside there stays just like it is. So remember, that's what this does. It says that this has to be positive. If you just have the number, you just make it positive.
Okay, so there's...
Because this is the same situation. You've got a even, and you ended up with an odd exponent. It has to be positive. But you just make the number positive.
So what is...
Yeah, the variables is where the absolute value is going to apply. Numbers, you know that it has to be positive. You can make it +8. But if you just write positive x, I can still plug in a -5. So without this absolute value, I'm saying it could be negative, and it can't. 36 is the same way, so I'll write that up here. You're just going to cancel the cube and the cube root part. You're going to be left with that parenthesis with the 512 minus, or 512 plus x squared. Do we need absolute value? No. Why not? Because the index is odd, and that's really all that matters. If it's odd, you never have absolute value. Under 37, the fourth root of 16 into the 8. So we do have an even index. Maybe you should check that every time. Just be ready to check all your exponents at the end. So what is the fourth root of 16? 2. And 8 over 4 would give you n to the second. So do we have any odd exponents with a variable? No. So that's finished. And 38, that will not be on the test. So don't worry about that one. That's one where you have to factor that into square, and then you square root it and cancel it out. So I just did all those for you. So I would highly suggest on 7.4, you flip back to that section and do some problems, or you grab some over on the chapter test on page 435, just to make sure you got that. So we'll keep going with these. Sixth root of 128. And again, you're not going to know what section these problems come from, so I would check that in your calculator and see, is 128 a perfect sixth? I would do the sixth root of 128. It is not. So what do we have to find then? What do we have to find? The biggest perfect 6 that goes into 128. So anytime you have these problems, I would start a list over here. And since your number is 128, you're not going to have to do very many. 2 to the 6th is what? 64. So we do 2 to the 6th, and that is 64. And that goes into there twice. I would, though, on your test, I would go ahead and type in 3 to the 6th just to make certain that I found the biggest one that goes in. What is it? 729, that's way too big. So you don't have, if this one doesn't work, it's on, that's it. So I tell you, and a lot of people skip this step, and I think it causes a lot of problems, to write 64 times 2. We're not changing the value. 128 and 64 times 2 are the same thing. We're just breaking it up so that we can simplify. So then what is the 6th root of 64? What? 2. So you bring that out front, and you have 2, 6th root 2. You leave this number underneath there. 3 times 2, 6th root 2. 5 square root 12 minus 3 square root 75. Again, mind what operation you're doing. Are you multiplying these two numbers? No, what are we doing? Subtracting. Are they like terms? The square roots are not the same, right? So what do we do? Simplify. So, is 12 a perfect square? No. So we find the biggest perfect square that goes into 12, which is 4. So we would change that to 5. 4 times 3. What's the square root of 4? 2 times 5. And we have 10 square root 3 minus, so we do the same thing with 75. What goes in there? 25 and 3. Square root of 25 times 3. So we have 15 square root 3. Now are they like terms?
Yes.
Yes, 10 minus 15. Negative 5 square root of 3. That's what you end up with. Number 42. Are those like terms, the radicals?
Yes.
Yes, they're exactly the same. That's an easy problem. So you have 6 of them, you're subtracting 8 of them, what are you left with? And negative 2 of those. 43. What kind of problem is that? It is a FOIL. That is a FOIL problem. What was the first square root? 8? Plus square root 12. And since it's squared, you must remember that is FOIL. Square root 8 times square root 8 is 8. Outside, I would go ahead and just multiply those numbers. So that would give you 8 times 12 is what? 96. And then plus square root 96. And then plus 12. Square roots cancel and you're left with 12. So for sure you've got 20. Go ahead and put those together. Plus 2 square root 96's. So would we be done there? No. Always make sure the radical is simplified. Because 96 is a perfect square. So what's the biggest perfect square that goes into 96? Times what? 16 times 6? That's correct. So we still have our 20 plus 2, and we're going to change that to 16 times 6. What's the square root of 16? And 4 times 2? So that becomes 8 square root 6. That would be your prime. You're going to be like 42. 42. Negative 2, 6 root 11.
Okay. I know.
44, I won't do, but that's multiplying. I'd multiply those 3 numbers and then simplify the square root. It's going to be a high number, so you have to divide. Number 45, square root of 243 over square root of 3. Can you do anything to that? At least on the bottom. So we have to get rid of this radical. How do we have to do that? We can't do it. It's simplified. It's square root of 3. Nothing you can take out of there. Multiply what? Square root of 3. Very good. Anybody know what we call that? It's rationalizing the denominator. So what is 243 times 3 multiplying these? 729. So we have the square root of 729. What do we have on the bottom? 3, because those radicals cancel. That's why we rationalize. Is 729 a perfect square? 27. So we end up with 27 over 3, which is 9. So remember that step on rationalizing. I will do 46. One over 3 plus square root 5. So this is dividing with the radicals. How do we get rid of the radical on the bottom?
I don't know what it's called.
The conjugate,
3 minus.
3 minus square root 5 on the top and the bottom. So the top's easy. What do we have? 3 minus square root 5. And the bottom we have to FOIL.
We only have to do
We only have to do first and last because they're conjugates. So what is first? 3 times 3 is 9. And last? Minus 5. So we have 3 minus the square root of 5 over 4. And then remember to check these 3 numbers and see if you can cancel anything out. You obviously can't when it's 3 and 4. Sometimes you can. So 47 will be the same way. So basically out of 7.5, that it's exactly the title is operations. So add, subtract, multiply, and divide those rationals, the square roots, cube roots. 7.6 was rational exponents, rewriting them. There probably won't be any that simple on the test where you just have to rewrite. We'll probably actually have to do some operation. 49 is 27 to the negative 2/3. Now, what do we know about a multiple choice test?
it. Guesses.
You have 4 guesses. That's true. What else?
I use the forward, backward.
You can work backward. What else? What did I say that you had to do on this problem in the homework? Do what? Not this one. We have a negative exponent. What do you have to do with a negative exponent? You have to put it in the bottom. Well, I know if you put it in the bottom on multiple choice. No, that's what I'm getting at. So get the answer. Just like the EOC test will be, get the answer. It does not matter how you get it. Your calculator will do this problem for you. There will be no work required to show. So if you type that into your calculator, what do you get? What? No, whoever said it was right. 1 over 9, that is the answer. 1 over 9. You would take that to the bottom, which is what I required in the homework. Since that's a negative, it would be 1 over 27 to the 2/3, and you get the same thing. So don't worry about showing that step, just get your answer. 9 to the 1/3 times 9 to the 5/3. You could actually do this in your calculator as well. However, I don't recommend it. It's more difficult. And if it doesn't work out like this one does, it won't work for you. So if you get a decimal, That would not be the correct way to work the problem. This one works out, so I would pay close attention to figuring out how you get that. So we're multiplying with the same base. What's the rule say to do with the exponents? Adam, so we have 1/3 plus 5/3 would be 9 to the 6/3 or 2, and your answer would be 81. Make sure you don't multiply the 9s. If you get 81 squared there, your answer is obviously going to be way larger than it should be. And I would almost guess that the test will have that answer on there. 81 squared, whatever that is, that'll probably be there. So make sure when you multiply with the same base, you just add the exponents. You do not multiply those numbers. So what are we going to do on 51? 51, you have to look at it and know what you're going to do on it. You're going to, how are you going to simplify? You're going to, are there any variables in it? There are. 51, are there any variables in there? No. So what would be a handy instrument? Type it in, see what you get. 9/4?
Yeah.
That is correct. I would always check that first to see if you can get a quick answer. We will not do problems like 52, 53, and 54. Make sure also, so I might look back at that section because you'll have those variable problems. So you cannot type that in the calculator. You do have to know the rules. So where's your smaller exponent? In the what? So we take that to the bottom. What's left on the top? On the top. 1, and we do 3/4 minus the 1/4 and get 4 x to the 1/2. And we would leave that as is. Same with the multiply. If you had the same problem there, only it was x to the 1/3 times x to the 5/3. Your answer is going to be x squared. So you have to know that you're going to add those exponents. And the last section, 7 on page 434, I'll probably put quite a few of these on there, so I would definitely know how to solve these equations. Square root of x plus 6 or equals 6. These are easy. You check, is the radical by itself? So we square both sides, and we get x equals 36, and that's so easy to plug in. What's the square root of x, or square root of 36? 6, it checks, that's your answer. 57 is the same way. Remember, you can change those to radicals, or you can leave them fractional exponents, it doesn't matter to me. Let's try 59, square root of x plus 5. What do you need to do with the 3? What do you need to do with the 3? Add it over, so basically we have square root of x plus 5 equals 3. Is the radical by itself? So what do we do? Go ahead and square. That cancels. Square, so we have x plus 5 equals what? Here. 9 minus 5. X equals 4. 4 plus 5 under the radical. 9, and the square root of 9 is 3, so it checks out. 4 is your answer. So looking at number 63, do you have to FOIL anything there? No. Remember, that each side of there is only one term. So which one would we have to FOIL on? $64 is, we would, that is correct. Let's do number 13. Over on the chapter 6, practice test problems, number 13. I would advise on a problem like 13 to put the radical part first. So I would do square root of x plus 5 plus 1 there. Equals the square root of x plus 12. So same type of problem as the last. Are we ready to square? Yes. So which side do we have to FOIL? The left. So that's going to cancel. I'll move that over here and have x plus 12. So multiplying first, x plus 5, and we'll be left with the x plus 5 radical cancels. So outside would be 1 squared x plus 5, inside's the same. And last would be what? 1. Combine your like terms. We have x plus what? 6. And we'd have plus 2 squared x plus 5s. So what do we know is going to happen that we can cross off? What's going to happen?
You're going to cancel your variables.
The x's are going to cancel there, so we can cross those off. Minus 6. So we have 2 squared x plus 5 equals 6. Divide off the 2. Squared x plus 5 equals 3. So we're ready to square again. So x plus 5 equals 9. Subtract the 5. X equals 4. And we always have to check. Because remember, most of the time when you square it twice, it doesn't work out. So what's 4 plus 5 under the radical? And the square root of 9? 3 plus 1 would give you 4. And over here, 4 plus 12, 16, square root of 16, 4. So that one does check out. X plus or x equals 4 would be your answer. So as far as assignment goes, you got about 20 minutes. Work on whatever you need to work on. You can go back and do the problems that we skipped over. You can go and do some problems off the practice test. But I do want you working on Algebra 2 until the bell rings. So be working on some review problems.